Today we have Haseeb Majid with us, and he will tell us about observability and how to make it painless. So yeah, please welcome Haseeb.
Hello everyone, welcome to my talk, Observability Made Painless with Go, Otel, and the Looks Good to Me stack. Don't worry if you don't know what most of those words mean, we will cover it, and hopefully by the end of the talk, a lot of this will make a lot more sense. So a little bit about myself. As you heard, my name is Haseeb Majid. I'm a backend engineer at a fintech startup called Nala. There's a link to my blog, which also houses these slides. I'll have a QR code at the end, so don't worry about going through the slides. You can go through them in your own time at the end. A few fun facts about myself. I really like cats. I'm an avid village cricketer. My brother told me to put emphasis on the word village when I was demoing this talk with him, so make of that what you will. So, who's this talk aimed at? Well, of course, it's aimed at those people who have perhaps heard about observability but want to know a bit more. We will cover that. Maybe you have an application and you want to improve the observability or see how you can make it more observable. Hopefully, you'll be able to pick up a few things. It's also aimed at those people who know observability or have some sort of observability stack set up, but you want to know more about OpenTelemetry or Otel. And how does that fit into things? What is that, right? And this was definitely me like 18 months ago. I vaguely knew what OpenTelemetry was, and hopefully by the end of this talk, you will be more familiar with it. We are not going to be covering much PromQL or Prometheus query language or Prometheus style metrics. We're going to go over a little bit, but that could be a talk on its own. Don't worry if you don't know what PromQL is. We will go over that a little bit. If you're already an expert in Otel, you might not get a lot out of this talk, but of course, feel free to stay. So let's go over a few definitions. What's observability? It's sort of in the name. It's basically in terms of we're going to be talking a lot in terms of HTTP services. I feel like a lot of people have written HTTP services, but it's basically what's going on with our application, and particularly what's going wrong with our application. If customers, for example, can't log in, is it customer support that's getting in touch with us and letting us know? Or are we a bit more proactive and we get an alert that there's been an increase in certain types of errors on Slack and we can try and fix it, hopefully before customers notice or with minimal customers noticing? And that's where observability is really important. It's basically what's going on with our app, and more importantly, has something gone wrong? In terms of this talk, we're going to be covering three main, what we call observability signals in the Otel world. You may have seen these referred to as pillars, essentially the same thing, but in the Otel world, I believe they refer to them as signals. So really quickly, logs, I'm sure most of us are quite familiar with these. It's like point in time, something's happened, right? 8:05, this happened, here's a stack trace, right? I think most developers are relatively familiar with logs. They give us a decent amount of context why something happened. And you know, we add them to our code and we collect and look at them on Datadog or Coralogix or wherever it may be. We have traces. I find traces developers don't know as well, me included, go back circa 18 months ago. But traces, essentially, what they allow us to do is view the life cycle of a user action. Sometimes you may hear people say it's the life cycle of a request. I think that can be a bit misleading because when people say request, people will think HTTP request, which is not, it's not like a one-to-one mapping. But for example, if the user presses an order button on your website, what's happening? And we will talk about that. They kind of give us this holistic view of the system, right? And because they contain a lot of context, a lot of data, typically we'll be sampling our traces because otherwise our storage costs can skyrocket. And then finally, we have metrics, which are there for aggregating numerical data, generally don't have a lot of context. And if, for those of you who are wondering what I mean by context, I will cover that. But essentially, we just mean like extra information. Metrics on their own don't give you loads of information. They're great for like kind of analyzing trends. And we'll kind of cover all three of these in some level of detail, particularly focusing on tracing in this talk. Hopefully, we'll be able to build something a bit more useful than this. But I suppose some observability is better than no observability. So they do say London has the most CCTV cameras of, I think, per square meter. So again, make of that what you will. For those of you who might be still confused, let's pivot. Imagine we own a pizza shop, right? A log message from a pizza shop or our pizza shop service, ordering service, might be order 123, large veggie pizza, burnt at 8:05 due to oven failure. So we've got a timestamp there. We've got some extra information about the order ID. We've got what kind of order it was and why it failed, right? So we've got a decent amount of context. A trace might look like order 1, 2, 3, took 30 minutes in total, 5 minutes to prepare, 20 minutes to cook, 5 minutes to deliver. And we could attach some extra context there. We could attach who ordered it, and we could attach what kind of pizza we were cooking as well. But generally speaking, that's what trace is. And then for metrics, it's going to be something like we sold 50 pizzas an hour. The average time was 8 minutes. And again, we could potentially split this by the type of pizza we were cooking, and we could drill down a little bit more. But there's not loads of context there. And of course, keeping our pizza shop service is really important, because I'm sure we can all appreciate pizza makes the world go round. It's the reason some people turn up to some of those meetups. Might be guilty of that. I don't know if Ferguson's in the room, but anyways. So some of you might be wondering, great, Haseeb, why does observability matter? Raise your hand if you've been woken up at 2 a.m. because of a production incident and you've had no idea what's going on. Yeah, about maybe half the room, maybe quarter of the room. So we've all been there, and we've all experienced when we just don't have enough tools or we don't have enough information to debug what's going on. And especially being sleep deprived, that makes things worse, right? So it's kind of that first bullet point there. Provide context to issues. So if users can't log in, why can't they log in? Is it because our block list service has gone crazy, right? Like it's blocking everything. Maybe we're locking users out. Or is it because people are just getting their password wrong? Maybe it's someone spamming our system to try and log in, right? It can also be useful for finding bottlenecks in the system. So Google, I think this is quite an old statistic, but over 50% of users will abandon a website if it takes more than 3 seconds to load, or app, right? So we want to make sure our systems are as snappy as possible, and bottlenecks in the system, finding them, if you're not observing things, if you're not collecting data, how do you know what's going to be a bottleneck? Maybe you can guess that this service is a bit slow. And particularly in this world of microservices, I think a decent amount of us are probably using microservices. And your particular microservice might just be 1 in 5 in the flow, right? And if yours is taking a second and all the rest are taking a second, all of a sudden that does add up quite quickly. Now, I know ops teams don't really exist per se, but imagine replace that with on-call. We want to avoid making the person on-call a pain in the ass for them. So we want to make sure it's working everywhere, and if it breaks, we want to make it clear why it's broken. So what's OTel, or OpenTelemetry? Just really quickly, for those of you who know about OTel, raise your hand if you say OTel. Raise your hand if you say Otel. I don't know which way around. Okay, so I'm in the majority. I think I'll alternate between the two. I don't think I have a consistent way, but I'll probably generally say Otel. Sorry, guys. But yeah, it's OpenTelemetry, which is basically this open standard where it came about because your data should be your own, right? So let me kind of take you back. What generally happened is we wanted traces. And don't worry if you don't know what traces are. I will show you what a trace looks like in just a second. But we wanted traces. So what would we do? We would have like a Datadog agent. And that Datadog agent would then collect some information, send it to Datadog, and we could view our trace there. Fantastic. Perhaps if you're using Kubernetes, maybe you're using like a sidecar or something like that, right? And that's fantastic. Except what happens now if you want to move to Jaeger or Zipkin or another trace provider and you're using microservices? 150, 100 services you have to go update that agent of? So that's where OpenTelemetry came around. There was a few others, I think, before that tried to solve this problem, but OpenTelemetry kind of is the industry standard. And essentially, what it is your application is now going to generate tracing information, and it's just going to export it somewhere. And it's going to export it to this thing called the otel-collector, which you can think of as kind of this proxy service. And it kind of decouples our service from worrying about traces or any observability signal. All of our stuff is going to go to this otel-collector. This otel-collector can then do transform, convert, whatever it needs to do. If we want to send it to Datadog, it can convert it to the Datadog format. If we want to send it to Jaeger, it can convert to the Jaeger format and then send it. It's just a couple of lines of config. If we want to send it to both, we can also do that. If we're doing a bake-off or something and we want to see what is the best provider for us. So we're just managing that all via config now, and it makes things a lot easier. And recently, quite a while now, but recently you can do metrics, and quite recently, I think logs are now out of beta, so you can actually manage all three, traces, metrics, and logs via OTel. And it can make kind of that instrumentation a lot simpler because we just export everything to the otel-collector, and that handles sending it wherever we need to go, and we can do that via config. This is a joke before people start telling me I don't know how probability works. I just found this on the internet, found it quite funny, but I think we've all been there where it just feels like most of our time is not spent writing code, it's debugging something. And it's even worse in production because you can't do breakpoints, you can't necessarily use a debugger, at least not in a very straightforward way. So I think making our lives easier is really, really important. So hopefully I'm going to be able to play this video here. So this is kind of what we're going to try and achieve. This is part of that looks good to me stack. We have Grafana here, and we have Loki, which is our logging database, right? And what we can see is we're getting logs as structured data, and we have something called trace ID and span ID in that kind of block. So this is all structured, and we can kind of search and filter and do various things. And we can also correlate between our different signals. So now we have gone via trace ID and found the trace in Tempo, which is our tracing database. Not a particularly interesting trace. It's just showing us the 401 error. There's some useful information there, unauthorized, failed, etc., etc. Right? So okay, and we have a rough time of how long it took. That's pretty cool. And then we can go back and look at the logs, and we can look at all the logs for this trace, and that could be across multiple microservices, and that can be really useful. I found this feature particularly useful outside of Grafana, wherever it may be, but that is really cool. We can then also just search from Tempo itself. You can just see me mess around a little bit. I keep forgetting how to use it. There we go. I find a trace. This trace is a bit more interesting because it has more of what we call spans, and we will cover spans in just a second. And we have something called attributes, and we can see us even interacting with the database in just a second. Over here, we can see that we've ran a query against the database, and we have an attribute which actually shows us the query we ran. Super useful for debugging. When something's gone wrong, we can hopefully see the query we ran as well and check that that's correct. We can also now go and look at Prometheus or Prometheus-like. We're going to be using Mimir, touch on that in a second. But we can look at some requests, some metrics, and we have these special metrics called exemplars, which we'll touch on towards the end of this talk. And that allows us to correlate a metric with a trace. So we can go, we see a 401 error, we can go and look at the trace and see why did we see that 401. These are not my recommended. This was just the default Google, YouTube ones. Oops. Let's come back here. Oops, sorry. There we go. Cool. So let's take a look at what an ordering service might look like for our pizza shop. So we've got the website there. The user presses the order button. The order button then goes to our order service, which goes to our user service, which then goes to Postgres and Redis and collects some information, goes back to the order service, which then saves stuff in Postgres. It then goes to the payment gateway, which then goes to Stripe, which then finally we publish a event to Kafka, which is consumed by the email service and goes to our SMTP server to send an email. You can see I'm out of breath just kind of explaining that flow. And in some places, this is probably quite simple. We haven't handled retries. We haven't really spoken about other things that could make this more complicated. So keeping this in your brain and trying to understand what's going on can be really tricky. So that's where tracing is really useful, because if we could visualize this in a trace, that probably makes our life easier. And especially if you're new to a flow, this becomes way easier to visualize. So this is kind of what I want you to think about when you're like, why is tracing or distribute tracing, as it's referred to, useful? So let's take a look at this example service. This is not production grade code. So if you see something slightly wrong, don't worry about it so much. This is just more the concept. We're just going to have a single HTTP endpoint here on our server, and it's just allowing us to search for a user based on an ID, right? And we're just going to search. We're just going to start a server on port 8080, and we're just going to have a single handler, which is just going to go to the database, fetch a user, return it, right? Cool. Not much observability, not much of what's going on. It's hard to tell, right? So we're going to instrument this, as they say, this application. We're going to add traces, logs, and metrics to this. Again, don't worry about this so much. This is more if you want to go through in your own time and follow this. We're going to download a bunch of Go modules here, mostly from OpenTelemetry, and get started. We're also going to set this environment variable. This is to do with that otel-collector I told you about. This basically tells our application where to export our observability signals, so our traces. And this is where our otel-collector is going to be running. Because this is a local setup, the otel-collector is just going to be running in a Docker container. We've set up some port forwarding. But the application doesn't worry too much. It just knows it needs to export it. there. If it can't export it, it will let us know that it failed, so that's always useful. But that's just what this environment variable is. We're going to be exporting all of our observability signals to this otel-collector, and then that can handle doing whatever it needs to do. So then we create a new function. We're going to call it new trace provider. Again, don't worry about following this line by line. I just want you to kind of understand this at a high level. We're going to set up an exporter, which is basically going to just export to that environment variable we just spoke about, right? It's going to use that environment variable and export our traces over there. Then we're going to set up a trace provider, and it's going to do some batching. So occasionally, every X seconds, it's just going to export all of our traces. We set that as our global trace provider. So whenever we reference tracing now using Otel, it's going to use this one unless we override it, which is, when we're getting started, definitely what we want. And then finally, we have this concept of propagators. And this is quite important because propagation is the mechanism that moves context between services, right? So what's really important here is that we need some way of moving this trace ID between most of our services. And how we do that, one of the ways is propagation. We use this trace context. And this is particularly concerned in the HTTP world. And this is going to happen via HTTP headers. So if the order service calls a user service, then we're going to pass that via HTTP headers, right? So we're going to set some tracing information in those headers, and it's going to send that over. And it's really important that we set this on all of our services. So when it receives a request, it knows, oh, this trace ID already exists. I'm going to carry on this trace, and I'm going to create what they call a new span. And that's really useful. So we're going to return that trace provider. For those of you who are wondering what the trace context looks like, so it looks something like this, and we'll break that down in just a second. And then in our main function, we're going to set up this new trace provider. We're going to check if there's an error, and we're just going to defer shutting it down so that if there's any traces, we can push them before the server shuts down, essentially. What we're also going to do is we're going to use some middleware available to us from Otel. And essentially what we're doing here is instrumenting all of our endpoints so that they will automatically trace, set up tracing. So either they'll carry on a trace if we get one, or if there was no trace information in the HTTP request, it will carry on, it will start a new trace, and we don't have to write any code to do that. It auto-instruments that for us. And then we just have a few things about how we're going to name the span. We're just going to do it via method and URL path just to make it easier to search. And then if you see that, just to have that around all of our endpoints, we're just going to have that M, which is the middleware wrap that mux. Just bear with me for a second because I realized we skipped some slides when I was faffing around with that YouTube video, so I apologize because we were supposed to cover this before and I was wondering why we didn't. So, spans are units of work for traces. They're the building blocks of traces, basically. In our code, we're never actually creating a trace. What we're doing is we're creating a span. And if there's a trace ID already available, so if there's some trace context, it's going to carry on that trace. And that is really important because if we don't pass that trace context along, what we're going to end up is 20 traces with one span each, rather than one trace with 20 spans, which is quite useful. So essentially what we're doing is we're linking spans with trace IDs. Right? That's essentially all you need to think about. So we're just going to go over spans really quickly. Again, there's not going to be a pop quiz at the end, so don't worry too much. But spans have a name, start and finish timestamp, which is how we can see how long they took. They have a context, which we'll look at just a second. And they have an attribute, which are key value pairs. One example we already saw was we had a key of DB query text, and then an attribute of the SQL query we actually ran against that. So we can kind of just put arbitrary data that we find useful for providing more context in our span attributes. Then we have a bunch of optional fields, a set of events, optional parent span ID. For those of you who are familiar with the concept of DAGs, or directed acyclic graphs, you can kind of hopefully start to understand how you could generate like this kind of directed acyclic graph where you have parents and children, and it's kind of easy to see the relationship of what calls what. So that really helps as well. We can also have optional links to other spans and a span status. And we will see some of that in just a second. So we have the span context here, and I visualize this as HTTP headers because that's how I kind of visualize it in my head, and that's where it really made sense for me. So hopefully that makes some sense to you. So we've got trace state there, which is a list of key value pairs for vendor-specific information. Remember, Otel is vendor agnostic, so sometimes vendors need special information, so we have that, but we don't really care about that too much. The trace parent is the kind of interesting one. So it's split by hyphens, but if we kind of break that down, the first bit is version. Currently, is always version 00. Then we have the trace ID, D for da-da-da-da. Then we have the span ID, 6E, etc. So that's part of that span context. Then we have some extra information about trace flags. 01 just means sample this trace, 00 means ignore this trace. So again, as I said, tracing has a lot of information. So hopefully that kind of explains this trace context, and making sure that trace ID is consistent and passed along, propagated, is really, really important. I'm going to quickly cover some other concepts that kind of confuse me, and hopefully won't catch you out when you get into this world. I was like, what's a link? What's a span link? Well, it's basically a way to connect two spans who are related but don't have a direct parent-child relationship. And some of us will be using event-driven systems, and it can be particularly useful there because you can't predict when something's going to start consuming because it's going to happen in its own time. It's asynchronous. So hopefully that makes some sense about links. Not used very often, but useful to know. We also have span events, which basically denote a single point in time. For example, when a page becomes interactable, maybe that's a span event. And there's a bit of confusion when to use attributes versus when to use events. You want to use an event when the timestamp is relevant. If the timestamp is important to that piece of information, use an event. Otherwise, just defer and use attributes. Again, just providing a bit more context to your span if you need that. And kind of the final thing I want to cover is spans can have types. You can either give them a type of client, server, internal, producer, or consumer. The default is always internal. And then there's a few other rules we follow where the child of a producer is always a consumer and the child of a client is always a server. And for those of you who are kind of familiar with these concepts, that roughly makes sense, right? So if we go back and look at a trace, the red blocks are basically our spans here. And hopefully you can start to see some of that child-parent relationship that we were talking about. We can see like how some of these attributes are useful. Again, this was all running locally, hence it looks pretty quick. In production, it will probably be a bit slower. But yeah, so we've got some information, we've got some names, we've got some timestamps, we've got some kinds there, which we already saw. We can see this case it errored, and we can see the relationship doesn't exist. And hopefully that gives us enough information to solve our problem. And if we take a look at span a bit closer, we can again see the attributes. We've got the query text, and then the actual SQL query we ran. Ignore that SQL query, it's just fetching some subscription info. It could probably be a little bit nicer, but hey-ho. Then we've got some events there, which I haven't really shown, and we've got some other useful pieces of information. So hopefully that makes sense. And now I can actually go back to where we should have been. So apologies again if for any confusion. So what is that middleware? So we spoke about this middleware that would auto-instrument our application and generate traces for us. What's that middleware actually doing? Well, in this case, the Go context or the request context here, what it's doing is this r.context will contain our tracing context. So we can actually pull tracing out of it. So it's going to inject that. And what's really important with all of our observability signals is we pass this context around correctly. So we want to pass the CTX object that actually has the trace context in it. Because if it doesn't have it, we're just going to start new traces, and that's not really useful. So that middleware is automatically going to start a trace or carry on a trace and inject the relevant tracing context into that CTX. And when we log, when we use metrics, we want to make sure it's that same context. So we want to make sure that middleware is kind of the one that runs first. So we can pull some information, like some span information. There's this thing called baggage, which allows you to pass key value pairs as well as a form of propagation. That can be kind of useful when you don't want to pollute your HTTP request with some observability info, right? You want to keep that clean, so you send that as baggage. Don't worry again about the code examples. I will have a service, an example service you can take a look at and use and go through in your own time that's actually in production. So that probably will be a bit more useful. We can also start custom spans if we want. Like if there's a critical part of our code and we want to make sure that is tracked, we can just start it. We just give it a name. So I've just named it after the function here. Again, making sure that that context variable, that CTX context variable is quite important. That's passed around. So we start a span like so. We can end it when the function ends. We can set attributes. As we said, those are key value pairs if we want. We can even record errors. We can record why it errored, and we can set the status as an error, just a database error. We can set optional attributes, so if the user's a premium. So you can do all this stuff. You can do your own spans. And hopefully, if the tracing context is passed properly, you'll be able to see that in Grafana or wherever you'll visualize your traces. And just to kind of summarize this, if we were to kind of take a look at this in a JSON format, this is perhaps what it might look like. We've got the context, trace ID, span ID. In this case, the span doesn't have a parent. We have the start and end timestamp. We have some attributes like some HTTP root stuff, which might be interesting. And then we have an event. right? So, and the event can have attributes as well. So you can also instrument kind of some of your infrastructure. So it doesn't just have to be your service. We can also do it with Postgres and other such things. So this will be available. I'm sure you'll be able to do this with any database. And you don't have to use PGX. If you're using PGX with a Postgres, you can just use this library like I have. And it's just one line of code. So one line of code where we set up the pool, and it will auto-instrument our code. So whenever we make queries against the database, it will include those spans. And if we take a look, we've already kind of seen this span a bit, but I didn't write any of this code myself to do this. It's all just coming from the library, and you can even see that at the top right. Similarly, we can do this with Redis or Valkey. We create our Redis client. We instrument that instrument tracing. Again, just one line, auto-instrumented. And out of the box, we can start to see traces like so. You can see the DB statement, and you can see some server address and other such useful information. You kind of get that free out of the box, don't really have to do much. So yeah, that's pretty powerful. One other thing to consider is the HTTP client you're using. So if the order service calls the user service, we need to make sure their headers actually get passed. So the tracing headers that we saw actually get passed. Now, every time we make a request, we could pull that information out of the context and inject it ourselves, or we could just set up a client using the Otel HTTP library to do that for us. And so now when we use this client, it's automatically just going to take what's in that context and set that as headers. And when the order service calls a user service, it's going to pass that information along. And we can do that just like so. Here we can just set, what we want to call the span. You can sanitize it. So if you don't want each unique one for each user, maybe you could replace that with ID, et cetera, because of path parameters and such. And then we can just call that client as we would. And again, that CTX variable, quite important that we pass that around, and that has that tracing context in, because when we create this new client and we make that request, it's automatically going to be injected into those HTTP headers. Hopefully that makes sense. And then equally, if we were to log that on like the user service side, we would be able to see the HTTP headers coming through, and we would be able to log that. Just one thing to note, if you are using this client for everything, note when you call third parties, you'll be sending those tracing headers. So just make sure there's nothing sensitive in there, especially if you're using something like baggage where you can set arbitrary key value pairs. Don't put any sensitive information there. And the final thing we're really going to talk about tracing in terms of infrastructure is you can do it with Kafka or event buses. So if you've got France Go, and this will work, I'm sure, for any library, is all we're going to do is we're just going to set the tracing context or add it as headers to Kafka. Very similar. I actually wrote code to do this myself before I realized it was a Kotel plugin. So we're just going to use that, and we set it up like so. We just set it up as a hook. And then we can produce and consume as we normally would. And if we logged just before we produced, we would be able to see that tracing information available. And then equally on the consuming side, if we were to process that record or that event, we would be able to see that on the tracing side as well. On the consuming side, we would be able to see the trace information. Hopefully that makes sense. And then that basically allows us to visualize the producing and consuming via our spans as well. And that can be particularly powerful because I think one of the biggest downsides to event-driven architectures is you do lose some of that observability that you might otherwise have. And the final thing I want to talk about with regards to tracing is sampling. As we've said, there's a lot of information that you collect from traces, as we've already seen. Sending all of that for every request, if you have 100 services, that might not be particularly useful. So you might want to sample some of your traces. And there's two main methods. There's head-based, which is basically you say, I want to sample only 5% of my traces. So 95% of the time, we're just going to throw that trace away. And that's called head-based sampling. So it's just probabilistic. When you generate a trace, it's just going to say, OK, there's a 5% chance. And we saw that with the headers. You remember the 0-1? That tells us it wants to be sampled. Otherwise, it doesn't want to be sampled. Tail-based is a bit more interesting, but a bit more complicated. With tail-based, you can, for example, when it's going to the otel-collector, you can set it up that for if there's any error, we want to sample that, right? Maybe for successful requests, we don't really care so much about sampling. We just want to sample a few. But for errors, we want to sample all of them. Or specific kind of errors, we want to sample all of them. And that's where tail-based is particularly useful. But then with tail-based, there's a few considerations. It needs to be stateful because it needs to keep things in memory. So if your service crashes, like the otel-collector and restarts, you can lose information. So it's just like everything. It's trade-offs, right? So yeah. That's sampling in a nutshell. Feel free to go look that up in more detail, but I just wanted to make you aware it's possibly something you want to look at. All right. onto our next observability signal. As I said, we spent a lot of time on tracing just because I know it's quite a new concept to lots of developers, so I thought it'd be particularly useful. But we're going to cover metrics kind of briefly. So metrics are there for storing numerical data which don't have a lot of context, and we will touch on what we mean by not a lot of context. But that makes them really fast to query and quite cheap to store. And we're going to store it as time series data. And by time series, we just mean we're keeping track of time, and we're going to kind of graph it along time and view the value. Most of you using metrics are probably using Prometheus-style metrics, visualizing them in Grafana and querying them using this language called PromQL. I'm sure that's most of what people are doing these days, and that's absolutely fine. In this case, what we're going to do is our application is going to generate OTLP or Otel-style metrics. It's going to export them to the otel-collector, and that's going to handle converting them to Prometheus. So we're still going to be playing around with PromQL, but we're actually going to be generating a slightly different type of metric. So really quickly, we have 4 main types of metrics. For those of you who might not be aware, we have counters for tracking ever-increasing values. So for example, the total number of requests, that's always going to be going up. We have gauges for measuring fluctuating values, so like CPU usage, memory usage, et cetera, et cetera. We have histograms for kind of observing the distribution of values, right? This can be particularly useful for like looking at latency of certain endpoints, et cetera, et cetera. Then we have the up-down counter for values that go up and down, things like queue size. But with up-down counter, we're more measuring the change, how much did it change? Whereas with a gauge, we don't really care about the previous value, whereas an up-down counter we do. So that's kind of the slight difference. We have async versions of these. You can go look them up. Again, there's no pop quiz at the end, so don't worry about if you don't remember all of this. It's just to give you a rough idea of the different kind of metrics we do have. And then really quickly, how does a metric look like? Well, it has a name. It has these things called attributes, and attributes are the things that add context to our metric. And for example, if we're doing like the total number of requests, some attributes that we might want to have might be the root, so the HTTP root or the endpoint we're calling, right? Because maybe we want to filter at that later on. Maybe we want to keep track of the response code because maybe we want to look at all of our requests that failed. When you're kind of creating the attributes, or as you might know them in Grafana as labels, you kind of already thinking about what you want to query. That's why with metrics, we don't provide a lot of context. We don't provide attributes with loads of values because we kind of have a rough idea what we want to query. Whereas with traces and logs, generally speaking, we don't really know what we want to query. So we give a load of information and then we can query that later on as we need. But yeah, so that's where attributes are. They provide a little bit of context, but we don't want attributes that provide too much. And we'll see why in just a second. Then obviously this is time series data. So we also want to store the timestamp. And then of course, the value that we actually want to keep track of, i.e. the total number of requests. It's 1,000 now. In 5 seconds, it could be 1,001, you know, et cetera, et cetera. So to set metrics, again, we fetch some packages. Don't worry about exactly what we're doing there, but yeah. Then we create a meter provider. We're going to set up an exporter just like we did before. This is going to export our metrics to the otel-collector. And again, the otel-collector is going to handle transforming them. We set up a meter provider like we did before, and it's going to periodically export our metrics. All good. We can auto-instrument our application to get some metrics, so we can collect some runtime metrics automatically, Go routines, that kind of stuff, heap, all that stuff that you might be familiar with. We can also instrument it to collect host metrics. So that can be stuff about CPU usage, memory usage. Perhaps you already have a mechanism for doing this, so you don't need to do this. In my case, this service was only running as a single container, so that was, I decided to collect some host metrics. And then again, we set that as the global meter provider, and that's absolutely fine, just for most use cases. And then we return that, and much as we did with the tracer provider, in our main function, we call it, check if there's any errors, defer the shutdown. Now, most of you who are exporting metrics from your service will probably be doing it with client Prometheus-style metrics. In the Otel world, there's not a lot of, I couldn't find a middleware. In the client Prometheus world, there's a bunch of middlewares you can just use that will allow automatically generate some HTTP useful metrics. So for those of you who aren't aware, basically the middleware is just going to be every time we receive a request, we're just going to set some metric information. So if we take a look at an example, again, there'll be a service at the end you can go and look at. Here we're just setting up a simple counter. So we're just going to increment this every time we receive a request. So we set this up once. Then we give it some attributes or some labels to give it some context. So the method key is going to be like, what was it, a get, a post, a delete. The response status code, was it a 200, was it a 500, was it a 400? And we can then filter on that later on. And then obviously the root, because maybe we want to look at how many requests each of our routes are receiving, or HTTP endpoints, right? And then finally, every time we receive a request, we're just going to increment it by 1, and then as a functional option, we just pass those attributes so that they can be added in. One caveat with attributes, though. For those of you experienced with Prometheus will already be aware, avoid high cardinality attributes or labels. What do we mean by high cardinality? Basically, I'm talking about that user ID there. And this is also what we meant by context. This is not the kind of stuff, generally speaking, we want to add. Again, there'll probably be reasons you might want to do so. But if we take a look, what's happening here? We could have 1 million users. We might have 100 endpoints, and we might have 5 methods with 20 status codes. I've exaggerated this a little bit. It's probably not that bad. But each unique combination of that generates what we call a time series graph, right? And each of those might take 1 kilobyte of metadata. And if we multiply that all out, and we have all of those combinations, we are going to generate 10 billion time series, which already is going to be 10 terabytes of data, just in metadata alone. If we remove the user ID, all of a sudden that becomes much more manageable, right? Obviously, Prometheus in reality will start to throw away metrics and do other stuff, but you probably don't want to lose all of your metrics just because you've added a user ID. So that's kind of what we meant by context and avoiding high cardinality metrics. Hopefully that makes sense. The final bit on metrics, I just want to kind of show you some metrics, visualizing them in Grafana. So here's what we were talking about with label filters, right? We added some, for context, the HTTP status code. So now what we're doing is we're just looking at the successful requests and we're splitting them by endpoint. So we can see the home page has received the most number of requests. Remember, counters are always going up. Then we got the fave icon and we got other pages, so it's kind of useful. I have made a slight mistake in this query. So you can see the promql at the bottom there with the sum by. Most of the time, I think people are building these with the Grafana query builder, but you can also write promql by hand if you wanted to. The mistake I made, and I'm sure some of you have already caught it, is that counters should never decrease. However, metrics are just stored in memory for your service. So guess what happens when your service crashes? The metric will go back to 0. And you need to account for the fact in your query that counters can go back to 0. So if it went back to 0, with this current function, everything would go down. Rather than the next time it received like 1 maybe, rather than showing 19 or 18 as we would expect for the green graph, it would show 1. And what you can do to counteract that is use rate and irate and other functions that Prometheus gives you to account for the fact that counters can go back to 0. This one catches people out. It caught me out. A senior developer told me off for it. So keep that in mind, right? That counters can reset back to 0 in your application, and Prometheus is not going to do anything for you to account for that. You have to do it yourself. Finally, I want to touch on histograms, because I think histograms are one of those things people don't know as well, and I was in that camp as well. So we can tell this is a histogram because we're looking at buckets. And what we're essentially plotting here is, if you can see, I don't know how well you can see at the back, but we're looking at the 95th quantile. And essentially, what we're saying is, at any point in this graph, so if you look at the green graph for the home page, what we're saying at any point, 5% of requests were slower than this. If we just looked at an average latency of our endpoint, it might say 100 milliseconds. We're like, fantastic, that's great. But we want to start looking at outliers, because even 1% of our customers could be 10,000 customers, 100,000 customers. And maybe when you look at like the slowest 5% of requests are going to be slower than 8.5. Maybe imagine that wasn't milliseconds. Maybe that's 850 milliseconds. And maybe that's really slow because, again, there's other microservices. And we're saying 5% of requests are even slower than that, right? So that's where histograms are really powerful. And for those of you who might not be as familiar with the maths, essentially what we're doing is we're storing these in these kind of buckets. And if we're looking at the 95th percentile, it's going to be somewhere between the 8.0 bucket, so LE is less than, so we're saying less than 8.0 seconds. And it's going to be somewhere between 0.8 and 1. Prometheus will do some extrapolation, and that's going to be roughly 0.94 seconds. Right? And all of a sudden, when we start looking at these outliers, histograms can be great for showing that and see maybe 1 second is too slow for our customers, for those customers at the top. Hopefully that makes sense. So that's kind of some of the power of histograms. On to logging. Sorry, wrong kind of logging. So, logs. I think developers are generally speaking quite familiar with them, so we won't spend loads of time on it. But it's essentially what's happened in our application, and it's the common way I suspect most of us are debugging our application, right? We're going to Datadog, we're going to Coralogics, we're looking at logs, we're trying to roughly look at the time when we know an error happened or an alert has gone off, et cetera, right? So some of you will be asking me, but Haseeb, why otel in logging? And to be fair, it also kind of applies to metrics. There's a few reasons. Context propagation. We can automatically attach our trace context to our logs. So we can inject a trace ID and a span ID automatically into our logs. We don't have to do that ourselves. Otel will handle that for us. Correlation. Linking logs to traces and traces to logs, really useful. If you take nothing else from this talk, if you're in microservices, if you're using microservices, and you don't have like a trace ID or a correlation ID between all of your logs, showing you all of the logs related to like kind of a request, really, really useful. Like you might not always bubble up the information, like, service A calls B, which calls C. You might have to go to service C to actually see the actual error and understand it. And that's been super useful for me in the past. A unified schema, we can kind of define these attributes and share them across all of our signals. Right? So we can just do it in one place and we don't have to worry about keeping them in sync. And of course, a reduced overhead. We don't have like 3 mechanisms for pulling observability signals. Everything is just going to be exported to the otel-collector, and that's all going to be done via config. We're going to be looking at structured logging. For those of you who aren't familiar with structured logging, just pretend it's like a JSON object. So rather than doing like a free text regex, we can just like search for specific attributes. We can say, find all the logs with this trace ID, with this key, and this value. And that means for Loki and other such logging databases, it's a lot quicker to query. Again, we're going to fetch a bunch of packages. Don't worry about that, modules. Don't worry about that so much. We're going to set up a logger provider as we have done before. We'll notice this min-sev thing, which we'll talk about in just a second. But yeah, we're going to export our logs as we did before. We're going to batch our logs. And then we have this min-sev thing, and that's basically to do with log level. Locally, you might want a log level of debug. But when you go to production, maybe you don't want debug level logs because they're too noisy. So you might want to set info or warning or error, right? You maybe only want to see error level logs. So that's where we're using the min-sev there, just to say throwaway logs are lower than this severity because we don't really care about them, right? So using severity in logs can be super useful for that. Then we just set up a log provider as we have before. Global here is part of the otel library, the otel logging library. It's not something I've done myself, but it basically just does the same thing as the rest of our code, which was just when we reference a logging provider, we're just going to be referencing this one by default. And that's absolutely fine. And then in our main function, we call it like we normally would, right? Like we've done the rest of our providers. We check if there's an error, et cetera, et cetera. Then we have to go a little bit further with logs, actually, unfortunately. Well, not unfortunately. It's just the otel team decided to take a different approach because logging is quite mature as compared with traces and metrics. And what they did is they came up with these bridges. And the bridge basically transforms your slog, we're going to use slog from the standard library, your slog record into something otel can understand. So for my setup for logging, for locally, I have a standard out logger. So that's just going to log to my terminal because that's quite easy to make it easier to debug. Then I also have this otel handler, which is going to use the slog library, and it's just going to make sure that the records are converted and sent over to the otel-collector, as we've seen. And then I just use this slog multi, so whenever I log, it logs to both, if that makes sense. It logs to standard out and the otel handler. In production, I don't care as much. I'm not really going to look at the standard out of like fly.io or whatever my provider is. So we just, I'm going to view that in Grafana. And then we return the logger as we normally would, and we call the logger as we normally would. You can pass it via struct, or you can pass it via context. And then, again, that CTX variable, as long as it has the trace context, if we did something like so, we would get output like that. And then the tin output looks something like this. It's nice just to view on the terminal, and the Grafana one we've kind of already seen. And then just really quickly to summarize, where might you use what? How many errors occurred? Probably a metric. Why did a specific request fail? You might start off with tracing, but you're probably going to solve that using a log. You're going to require detailed error context. Is latency increasing? We've kind of already seen what we were looking at. We were looking at the P95 latency, but that's going to be a metric again. We're going to be looking at latency via metrics. Things like bottlenecks, probably traces. Why did a request time out? Again, probably a trace. See what took so long. Why is the user not able to log in? Probably going to be a log. But yeah. Going over really quickly just a few other otel concepts that I was wondering what they are. So we have these things called resources, which basically just describe the source of the telemetry data. So for example, if you're in a container in Kubernetes, maybe you want to attach some kind of metadata to our observability signals. You can do it via an environment variable. or you can do it via code. And so, for example, the deployment environment key is really useful because for lots of my setups, I just have one set of, like, say, Grafana, and then I can just filter on using the deployment key, dev or production. And you can attach lots of other useful information, and then you could potentially filter by, oh, this container is misbehaving, why is it misbehaving? And you can look at just specific data just to that. And then we can pass this as a functional option. You might have also seen the semconv library, semantic convention. That's basically just to give us kind of these consistent names or strings, so we don't have to worry about naming, and that will be common across languages and tools. So we saw it with our attributes here, and we see semconv, and basically we get strings like so. And if you did it in Java, it would be a string, etc., right? Finishing off the observability part, some anti-patterns to avoid. Emitting a log for every HTTP request. Use a metric instead in production, might be fine locally. Trying to capture a user ID in a metric, we've already seen, don't do that. Generally speaking, use logs and traces. And logging without trace IDs, please try and use trace IDs. It just makes your life a lot easier, especially in the microservices world. The final part of our talk, we're just really quickly going to go over the Looks Good to Me stack. I think it's just a really cool acronym. So what it stands for is Loki for our logging database, Grafana for kind of visualizing everything, Tempo as our tracing database, and Mimir as our metrics database. Quick note on Mimir, in production, you will probably using Prometheus and Mimir as a backend instead of Thanos. Don't worry if you don't know what that means, but essentially just to simplify our local setup, I just use Mimir, and then it fits quite nicely into the Looks Good to Me stack. And essentially, this is what we're achieving here, right? We're collecting OTLP data. That's going to the otel-collector. It's then via config going to send it to Prometheus, Tempo, and Loki. We're then going to connect those as data sources to Grafana and view that on the Grafana UI. That's essentially what we're doing. I think this is a great diagram from the team. We're running a bit behind, so I'm not really going to go over the Docker Compose setup much, but there'll be an example at the end. But it's essentially just spinning up all those things we just spoke about. So a little bit about the otel-collector. I've spoken about it a lot, and I think this diagram explains things really well. The otel-collector can receive data in a number of formats. So OTLP, Jaeger, Prometheus. It can then batch, transform, filter. Your security team might love it because you can start filtering logs. If you see like 16 digits split by hyphens, ooh, could be a credit card number. Let's make sure we don't actually send that to our logging provider, right? And then we can transform data, and we can send it in the Jaeger format, Zipkin format, whatever it may be. We could even send it, keep it in the OTLP format if we wanted to, because lots of our providers now actually support OTLP, metrics, traces, and hopefully soon to be logs. Obviously, in our case, we're converting stuff into Prometheus for metrics, and that's how we visualized it. So in terms of the otel-collector, the one I actually went with is Alloy, which is made by the Grafana team and has this nice UI, but basically does the exact same thing as the otel-collector, just in a slightly different config language. They say it's a bit easier to integrate with Kubernetes and a few other things, but for all intents and purposes, you can use the otel-collector, you can use Alloy. I quite like the UI just to be able to see everything is set up properly. We can see Loki there, we can see Prometheus, and we can see the default OTLP exporter. One other thing, part of Grafana that I like setting up was setting up data sources, but rather than doing it via the UI, you can do it via code. And it makes it easier for new people to get set up, and if you lose your Docker volumes, it can make it a bit nicer. And this is how essentially we were correlating our data when we saw in the YouTube video. So if we have Prometheus here, we have this thing called exemplars, which is how we went from a metric to a trace. So it's just like if you see a trace ID, use the data source Tempo. Loki for our logs, we have this thing called the derived field, and that's basically just doing a regex check. And if it sees a trace ID, you can search that trace ID for our data source Tempo for our traces. And that's how we linked logs to traces. And then finally, we have Tempo, which is for tracing. And that will use trace to logs and trace to metrics, so we can link our traces to logs and metrics as well. And really quickly, in the Grafana UI, if it's set up properly, oh, I appreciate that, it is really terrible. You can't see that at the back, but if it's set up, you can do something like so. And for metrics, you need to enable these things called exemplars. Exemplars really confused me when I was looking up for this talk. They basically are just a special metric that gets produced every now and then. So it's not like every metric has it, but they just have a trace context attached. So it has basically the same data as a normal metric, but it just has a trace ID, so we can search for that later. And it looks something like this if you were looking at the JSON. It's very similar, except with some tracing information. And then finally, with traces, if it's set properly, we'll be able to see we're referencing Loki and Grafana. And if we wanted to just, before we finish up, if I was to take a look at viewing an error, imagine I've gone out for lunch and I've come back and everything's on fire. I quite like community. I appreciate it's probably not the best meme to use, but here we are. And we see an increase in 401 errors. Maybe I go to our Grafana dashboard. We've got exemplars, which we just spoke about. Again, notice how it's not every metric. It's kind of a special metric. I see a specific exemplar. I click that exemplar, and it goes and takes me to tempo for tracing. So we kind of see our trace. We get a bit more information. We see what's happened. We see how long it took. We see the user 401. Still don't quite have enough context. So we go take a look at logs. Oh, okay, failed to get state cookie. The user didn't have a cookie that we expected them to. Makes a lot of sense. And that might be like a flow that you use to kind of debug and see what's going on. And hopefully you can see the correlation in that kind of looks good to me stack can be quite useful. Of course, you can use whatever you want to do. And now our pizza shop is up and running and it's fully observable. Thank you very much. There's a link to these slides and the example service at the bottom. Thank you for listening. I appreciate that was a ton of information. So don't worry if some of it went over your head. And yeah, thanks to everyone who helped review this talk and provide feedback.
We're doing questions?
Yeah, absolutely.
Okay. Does anyone have questions? Yep.
Thank you very much. That was amazing. How much of your code ends up being non-code, but just Otel in the end?
So in like at work, what I generally would do, or what we've done, is we've abstracted a lot of it out to libraries. So you kind of have one library that every microservice imports, right? So a lot of that just gets moved out. And then if you need specific stuff, then you would add it. So not a lot. If you're like me and like Banterbus, for example, is just a single service, then yeah, a decent amount of that percentage is like maybe like 10% of the code does end up being kind of observability related. But it's kind of like if you're using that, if you have a library, it's like most things, right? You kind of get those economies of scale, and you kind of just have to write it once and it does it for you. If it's just for a one-off service, then yeah, it can start to add up. But you know, with metrics, you would have to do that anyways, whether using OTLP metrics. The logging is just a little bit more. You'd have to add those logs anyway. So it's probably only the tracing bit really that adds a bit more. But you'd again need to start those traces yourself. So even if you weren't using Otel and the looks good to me stack, you would still probably need some. I don't know if that was exactly your question, but hopefully that answered it.
So can you use Jaeger or Prometheus, one of those for Otel? Because I have seen that sometimes Jaeger is being used for traces and Prometheus for monitoring.
Yeah, so sorry if I wasn't clear. Yeah, Prometheus is a metrics basically backend, right? So what you can do, for example, when I was talking about the otel-collector, it was some of those specific observability signals can be converted. So metrics can be converted into Prometheus format. Traces can be converted to Jaeger, Zipkin, Datadog, whatever other format you may need. Though again, a lot of providers now support the OTLP format for all of these, so you can just keep them in the OTLP format. But yeah, no, absolutely. Like Jaeger is a tracing provider, as far as I'm aware, for visualizing your traces. You wouldn't. I don't think you'd be sending metrics there, as far as I'm aware, anyways. Someone can correct me if I'm wrong.
Thank you. Any more? Yeah.
Thank you for the talk. It was really great. Do you ever think you can have too many metrics, logs, and how do you advise preventing too much noise?
Yeah, I think that's a really good question. I did actually delete some slides just last night where I was talking about lessons learned. Overlogging, I would always push for overlogging than underlogging, but it basically will just come down to when you're in an incident, probably looking at that log and being like, that's useless. I think unfortunately, at least in my experience, that's what it boils down to. Or when you're trying to debug an issue and you're like, you know what, that log is useless. In terms of metrics, yeah, metrics can be one of those things. It can be really hard to kind of work out. And I think unfortunately, some of my learnings have just been from you're in an incident, you're like, oh, that information would be really useful. Or looking back and saying we should have a metric tracking that. Yeah, trying to be looking forwards is, I think a lot of it is just learning from experience. At least for me, I don't know if there's other methods people use, but yeah.
Thank you. Okay, question in the back.
There's also some links at the end. You can go and have a look. Better Stack do some really good videos and some really good blogs. So
Hi, thank you. That was a great talk. Really appreciated it. Got a question on trace IDs. I've seen the term correlation ID used, and it's not very clear to me whether they mean exactly the same thing or if there is a difference. How do you see it?
So I think, apologies again if that wasn't clear, correlation IDs basically kind of existed before traces. So it was a way to like correlate like kind of the life cycle of something together. Basically, I wouldn't use a correlation ID. I would just use a trace ID now to do that all for you. Like you just have a trace ID, which is now tracking the life cycle of an action or a request, and just a filter on trace ID to view everything related to that kind of event or whatever you may call it. But yeah, correlation IDs I think just existed, generally speaking, before tracing became popular. It was just a way, before you could even look at traces, as a way to kind of correlate logs that are related together.
Right.
If that makes sense.
Yeah, okay, thank you.
Thank you. Any more questions? Yeah.
Thanks for the talk. I have a question about the trace ID.
Yeah.
So what if you don't have a microservice architecture, so the way I understood it is you create a trace ID when the user logs in, and that same trace ID goes around in the HTTP headers, right? And then you track the entire thing end to end, right?
So not quite. So you could do it. That's probably more, you have like a user ID and you'd attach it to your traces.
Right.
A trace ID is basically almost, trace is more of a user action. So when they press the order button, you could do it from the front end, you could do it from the back end. It depends. Like if you're using Sentry, you could also, like that's another popular tool. If there's a trace ID, by the time the request reaches the backend, it will carry on that trace. And obviously, if all of the spans are going to the same place, like Sentry, for example, you could visualize it there. But essentially, every user action they're doing will generate a new trace. And if you want to correlate it back to the user, you would attach the user ID where you can. Does that answer your question?
So like we pass the trace ID around when the microservices are talking, right? It's not like when the user logs in and they add something to cart, it's reusing the same trace ID. That's not how.
Generally speaking, no.
Okay.
Because then what would happen is when you visualize that trace, you would just get everything.
Right.
So it's kind of just like generally speaking, and again, there's good reasons to break these rules, but generally speaking, think about an action a user does. So user adds an item to a cart. That's an action. What are all the services that are touched? What are the pieces of infrastructure? What happens for that one single action? Then they add a second item to the cart. Then they go to the order. Those will be like 3 separate traces with 3 separate trace IDs, generally speaking.
Right, makes sense. Thank you.
So was that? Potentially, yeah, potentially.
Hi.
Sorry, if you could just repeat that.
I just said in the case of a sequence of actions, from my perspective, like adding to I don't remember what the other ones were out of the 3, but what I was saying, maybe you can use span links, which I think is something that you mentioned. I mean, that is to actually, I'm not sure how it would work. Maybe the root span in each of the 3 traces, they could be linked to one another, or maybe that's just an idea off the top of my head. If it's useful in some way, that's just it.
I think generally speaking, I'm not an expert in this, but generally speaking, you would link them probably via user ID. And if you want to send that round, that's where that baggage propagator, you can go and kind of look that up, becomes quite useful. I think generally speaking, my understanding is you want to keep traces kind of short, as in they shouldn't be running for hours, kind of sort of thing. But yeah, span links potentially. I'm sure there might be good reasons. I haven't.
Actually, I think your direction might be better, as I understand it. Maybe really some ID, not your user ID, because it can be maybe like sort of a card ID or a transaction. Yeah. Okay.
Yeah. Again, you can set that past that round. It's all business logic. I think someone here had a question.
Yes.
I suppose on that note, is there anything good for capturing, say, a journey like, a user having a conversation with an LLM and you're essentially trying to trace, how long it takes between responses. So sort of like doing that sort of trace level, like a trace, except it's a conversation between a user and and something?
Yeah, it's a good question. It's not something I've really thought about, to be honest. Because basically you'd again just be searching. The only thing I can think is you'd be searching on user ID and kind of viewing all those traces, and it's not. Maybe you want to attach some form of metadata you could then search from. But yeah, catch me at the end if you have any more questions. I'll be outside.
Yeah, thank you, folks. We are out of time, so 15-minute break now. But say thanks to Haseeb again.